Question 5, part A. What is the order of rotational symmetry of the shape below? So rotational symmetry, if you rotate something, it means you turn it. So it's asking for how many times you can turn this shape so that it fits exactly back onto itself within a 360 degree turn. So some people can see this straight away, others people need a little help with tracing paper. So what I've done here is traced over this shape onto tracing paper, and it doesn't have to be perfectly neat, just quickly will be fine. And I've drawn an arrow to show which way the shape was facing when we started. So if I now turn my tracing paper, and again it hasn't fitted on itself at all yet. Now I'm not back at the start because my arrow is facing down here, and the shape is fitted exactly onto itself once. Now I can keep turning it to try and get back to the start. Not quite fitted on it yet. And now the arrow is facing this way and it's fitted onto itself for the second time exactly. Still haven't turned 360 degrees yet, and now I have, and I'm facing the right way and it's fitted back onto itself again. So this shape has an order of rotational symmetry of order 3. So that there will give you 1 mark. So it says here, name a 4-sided shape with rotational symmetry of order 4. So that means it will be turned and it will fit exactly onto its original self 4 times before we turn 360 degrees. So here are some quadrilaterals. There's a square. So a square, we know that these 2 sides are parallel and they are the same. And these 2 sides are parallel and they are the same. And it has 4 angles of 90 degrees. So if I turn that shape now, again, so I've drawn around it with tracing paper, put an arrow facing upwards. If I turn it, it fits onto itself once, twice, 3 times, and 4 times. So a square has rotational symmetry of order 4. A rectangle, so that has these 2 sides are parallel and these 2 sides are the same, and those 2 sides are parallel and those 2 sides are the same, and again it has 4 angles all of 90 degrees. So if I try and turn this now, arrow facing up, it doesn't fit onto itself until we get here, so that's 1, and then back again, that would be 2. So the triangle has rotational symmetry order 2. A parallelogram, same thing again. If we turn it, doesn't fit back onto itself until it gets here, arrow pointing down, that's 1, 2. So the parallelogram has rotational symmetry order 2. The rhombus, so a parallelogram has again 2 parallel sides. A rhombus, this is like a squished rectangle. Rhombus is kind of like a squished square. So these 2 sides are the same and those 2 sides are the same. Well, they're all the same, sorry. So now arrow facing upwards, not fitting onto itself, still not fitting until we get here, so that's 1. And 2. So that has an rotational symmetry order of 2. This is a kite, so we have these 2 lines are the same, and then these two lines are the same. So a kite that doesn't have any rotational symmetry, so pointing upwards, it's not fitting onto itself, still not fitting onto itself, still not fitting on. There. So because it hasn't fitted onto itself at all until it got to 360 degrees, that has no rotational symmetry, or a rotational symmetry order 0. It's because these two lines are shorter than these two lines here. Trapezium, these two lines are parallel, so they will never meet. Again, this has no rotational symmetry, so that would be order of 0. So it doesn't fit onto itself at all until it gets back to 360 degrees. So those are our quadrilaterals. There is only one of them that has rotational symmetry of order 4. So you have one mark here if you say square.